Okay, so Unit 6 review for book problems.
Page 346, number 57. It's just one further.
Page 346, number 57. Okay, so an oxygen gas container has a volume of 20 liters. How many grams of oxygen are in the container if the gas has a pressure of 845 millimeters of mercury at 22 degrees Celsius? Okay, so we're going to make a list. We were given the pressure, 845 millimeters of mercury. The volume is 20 liters. We don't know how many moles. And R, we have to be careful with which R we choose. So in this case, R is the one that has millimeters of mercury in it, which is 62.4 millimeters of mercury per mole Kelvin. And then our temperature is 22 degrees Celsius plus 273 or 295 Kelvin. So these are all of our givens. And choosing R is important. You want to choose the R that has the pressure unit in it that your pressure is. They have to match. This is also torr. It would work the same. And then there's another one for atmospheres. Okay, then once we find N, we can go from moles to grams using the molar mass. So PV equals nRT. 845 times 20 liters, 62.4, and 295 Kelvin. We have 0.918 moles of oxygen, which is O2. So 1 mole of O2 is 16 plus 16, 32 grams of O2. And we wind up with 29.4 grams of oxygen. On the test, don't forget diatomics. They come in pairs. Questions about this?
So will we have that 62.4?
Both of the R's will be written on the test somewhere. They'll be
Okay.
given. Okay?
Page 340,
Page 340? Oh, it's 339 on here. 339, number 47. A 124 milliliter bubble of hot gas at 212 degrees Celsius and 1.8 atmospheres is emitted from an active volcano. What is the final temperature in degrees Celsius of the gas in the bubble outside the volcano if the final volume is 138 milliliters and the pressure is 0.8 atmospheres, if the amount of gas does not change. Okay, so initial pressure, 1.8 atmospheres. Initial volume, 124 milliliters. And initial temperature, 212 Celsius, has to be in Kelvin, so 485 Kelvin. It's coming out of a volcano, so it's hot. Initial or second pressure, 0.8 atmospheres. New volume, and we're solving for new temperature. So this is combined gas law. Um, 1.80 times 124 over 485 equals 0.800. Mm. 240 Kelvin, right? Let me check that. Yep. Minus 273 to get it in Celsius. Negative 33 degrees Celsius. Questions about that? Okay. Three 42. 53B. Use the molar volume to calculate each of the following at STP. So the molar volume just means that there are 22.4 liters per mole at 1 atmosphere and 0 degrees Celsius. So that's what STP means. The volume in liters occupied by 2.5 moles of nitrogen. One mole is 22.4 liters. So this is just a conversion problem. And we get 56 liters. This is important. 1 atmosphere, 273 Kelvin. Questions about that one? Okay. Next.
Page 337.
A gas sample has a pressure of 766 millimeters of mercury with an unknown temperature. The same gas has a pressure of 744 millimeters mercury when the temperature is 22 degrees Celsius. With no change in volume or amount of gas, what was the initial temperature in degrees Celsius of the gas? Okay, so this is the pressure and temperature relationship. So P1 is 766. With an unknown temperature. P2 is 744 at a temperature of 22 degrees Celsius. Remember that has to be in Kelvin. So 295 Kelvin. .766 over T1 equals 744 over 295. These are millimeters of mercury. Cross multiply and divide. And we get an initial temperature of 304 Kelvin, but they wanted Celsius, so subtract 273, and we get 31 degrees Celsius. Pay attention to what units it's asking for. Temperatures have to be put in the equations in Kelvin, but that doesn't mean that you have to report it in Kelvin. And your multiple choice choices might be Celsius. So just pay attention. Okay?
Page 342, 53A.
So this one, use the molar volume, which is again 22.4 liters per mole. Use the number of moles of O2, the number of moles of O2 and 44.8 liters of O2 gas at STV. So 44.8 liters, 22.4 liters per mole gives me 2 moles of O2.
Page 339 for 46B.
46B.
Yeah.
A sample of argon gas has a volume of 735 milliliters at a pressure of 1.2 atmospheres and a temperature of 112 degrees Celsius. What is the final volume of the gas in milliliters when the pressure and temperature are changed to the following if the amount does not change? Okay, so we have an initial volume of 735 milliliters. We have an initial pressure of 1.2 atmospheres. An initial temperature of 112 degrees Celsius, which is 385 Kelvin. And then for part B, they tell me my new pressure is 0.55 atmospheres. And my new temperature is 75 Celsius, which is 348 Kelvin. And I need to find my new volume. My pressure units match, so I can go ahead and plug in P1 times V1 over T1 equals P2 times V2 over T2 cross multiply, so I'm going to go ahead and show that work. 1.2 times 735 times 348 gives me 306,936 equals this times this, 385 times 0.55 to 11.75 times V2. And I get a new big volume, 1450 milliliters. My pressure and temperature both went down. Those have opposite effects on the volume, but the pressure change was what really made it expand. Okay.
Page 357 under 87.
357, 87A.
Yeah.
An airplane is pressurized to 650 millimeters of mercury. If air is 21% oxygen, what is the partial pressure of oxygen on the plane? So partial pressure just means if you have your total pressure of 650 and it's 21% oxygen, you just take that times 21% to get your pressure of oxygen. So 650 times. Just a percent. A gas sample has a volume of 4,250 milliliters at 15 degrees Celsius and 745 millimeters of mercury. What is the final temperature in Celsius after the sample is transferred to a different container with a new volume and pressure? Okay, so this is 357.91. This is combined gas law. V1, 4,250 milliliters. P1, 745 millimeters of mercury. And T1, 15 degrees Celsius, which is 288 Kelvin. The sample is transferred to a different container with a volume of 2.5 liters and a pressure of 1.2 atmospheres. We're supposed to find the new temperature. Before we can do that though, our units have to match. So these have to match. I'm going to go ahead and convert this to liters. So 4.25 liters. And I'm going to convert this to atmospheres. 760 is 1 atmosphere. Gives me 0.98. Then I plug them in. P1 times V1 over T1 equals P2 times V2 over T2. Cross multiply. Gives me 207 Kelvin. Which is negative 66 degrees Celsius. Trickiest part, make sure your units match. If you're asked for Celsius, subtract 273. A sample of gas with a mass of 1.62 grams occupies a volume of 941 milliliters at a pressure of 748 torr and a temperature of 20 degrees Celsius. What is the molar mass of the gas? This is a tricky one. Molar mass is grams per mole. I was given grams, so if I have moles, I can divide the two to get the molar mass. So PV equals nRT. My pressure is 748 torr. My volume is 941 milliliters. I don't know N. The R I want to use is 62.4 liters torr per mole Kelvin. And my temperature is 20 degrees Celsius or 293 Kelvin. My volume has to be in liters, so I'm going to convert that to liters. And then I can plug them in to the ideal gas law. I get 0.038 moles. So my molar mass is 1.62 grams divided by 0.038 moles, which gives me a molar mass of 42 grams per mole. question? That will be on the test, solving for molar mass. Okay.
Page 346.
65?
55.
55. 346. Calculate the pressure in atmospheres of 2 moles of helium in a 10-liter container at 27 degrees Celsius. Okay, so pressure we don't know. Volume, 10 liters. Moles, 2 moles. We want our pressure in atmospheres, so we want our R to be the atmospheres, which is 0.0821 liter atmosphere per mole Kelvin. And temperature, 27 degrees Celsius plus 273 gives me 300 Kelvin. Ideal gas law. Plug in the numbers. When you solve it, you get 4.93 atmospheres. A single patient hyperbaric chamber has a volume of 640 liters at a temperature of 24 degrees Celsius. And we want the pressure to be 1.6 atmospheres. We're in atmospheres, so R is 0.0821. And we're solving for the grams. Hi. Oh, hi. Lulu, your friend's here. Come here. Look who it is. Look.
Hi. Hi. Did you get all science stuff today? Yeah. All right, I'll bring her back.
You're good.
You need to leave, like.
Yeah, like, if you
I'll
can have her
bring
here,
her for the
310,
dogs.
yeah.
Hi. Hi. Come on, let's go.
Okay, so we need to know how many grams of oxygen, but we're going to have to solve for moles first. So we're going to solve for N. PV equals nRT. P times V times T 41 moles. That's a lot of moles. But 1 mole of oxygen is 32 grams of oxygen. I need 1,310 grams of O2. Don't forget the diatomics. Just because it says oxygen doesn't mean it's not O2. It's always O2. Okay.
62B on 346.
62B. Determine the molar mass of each of the following gases. So they give you the grams, and we need to find moles. PV equals nRT. P is 760. V is 2 liters. We don't know N. R is 62.4. And T is 0 degrees Celsius, which is 273 Kelvin. PV equals N R T. Point 089 moles. Molar mass is grams. 1.43 divided by moles. Grams per mole. Okay, I think I've worked almost every type of problem at this point. Does anybody have a lingering question that they wish I would work? Something that you haven't seen yet? Okay. Tomorrow for A students is a work day. I'll be posting the B video tomorrow, like I'm posting the A video today. And then Thursday and Friday you'll take your tests.